Today we're going to talk about Hopital Rule. Sometimes I pronounce it hospital. It's very similar to hospital, so it's very easy to remember. And myself, I really favored on using this rule to prove whether the sequence is convergence and divergence because it's very simple and straightforward because I just need to know. So let's say when we have a limit and approaches infinity, let's say is ln n over n. So when I got this one, we got something indeterminate. We can't determine whether it is convergent or divergence. And in this case, when we encounter something here, indeterminate, and we apply Hopital rule. Hopital rule is that it says the limit and approach infinity, whereby we differentiate of this thing over differentiate of means we differentiate the numerator and we differentiate the denominator. It's the same as the original equation as to a function. Means we can apply the Hopital rule where we differentiate this term and differentiate this term and they are the same. And this is called Hopital rule. So let's look how we can apply this one. So this is my function fx, this is my function gx, and because it's indeterminate, I use this rule, I differentiate this one, ln n. If we know differentiate ln n, I should get 1 over n. Over is over here, differentiate n, I got 1. So I copy down the limit. And it's equal to limit n approaching infinity, which is 1 over n. So as from here, I can substitute infinity here because this form is not an indeterminate form, so I cannot apply Hopital rule anymore. So I straight away put 1 over infinity, substitute as n, and I got 1 over something very big, which is 0, and prove that this is converges. And this is how one example of using Hopital rule. Let's look at another example. Let's say I want to find out the limit for n approaches infinity, 1 over 2n, 1 plus 2n. Okay. And straight away we substitute the infinity here, we should get something indeterminate form because negative infinity over infinity. So when it's indeterminate, so we use the Hopital rule, which we differentiate this one in respect to n. So we will get negative 2, right? I copy down. This one is negative 2 over, if we differentiate this term, we get 2. So negative 2 over 2, which is 1. And there's no n term here for us to substitute infinity, so therefore the answer is negative. And therefore the answer is negative 1. And this is converges at negative 1. Okay. Let's try another example. You can try this up on your own to test it out your ability. All right. For this case, I also can't determine because infinity over infinity is indeterminate form. So we can go ahead to use Hopital rule. If we differentiate n, of course we get n. How about we differentiate 2 power of n? If you still remember, is with ln, the number here is 2, and then copy down to n. And I have to put my limit. Okay. Approach infinity. All right. So at this point, it is not indeterminate form, so we straight away put in the infinity, substitute ln 2 over 2 power of n, up 2 power of infinity. As this case, I write like this, ln 2, 1 over 2 infinity. So 1 over 2 infinity is a number divided by infinity, which is 0. So at any term times 0, we will get just 0. And it converges at this point at 0. Okay, so that is for the Hopital rule. And next video, we're going to talk about, we have some common lists and how we can use this list to prove whether the limit is converges or diverges. Okay, see you.